Good morning. This is Unit 1, Day 2, notes for the limits involving infinity. So let's kind of recap. We have already taken a look at limits that are approaching a number, okay? So that was something like here, if you have a limit approaching a number, the first thing you always do is plug in a number. If you get a 0 over 0, that kind of shows you there's some sort of a trick and that you need to do something like factor or multiply by a conjugate, etc. So in this case, we factored. Then you can cancel, okay, and then you can plug in after you cancel, and then you get a number. But today we're going to look at what happens if when you plug in, you get a number divided by 0. Well, recall that a number divided by 0 indicates that there is a vertical asymptote. And so think about it. If you're approaching some sort of vertical asymptote, your choices is that you're either going to go to infinity or negative infinity, or the limit will not exist, right? Because if you're approaching a vertical asymptote, you've got two choices. You're about to hit it, you're either going to go up or you're going to go down. So that's when we're taking a limit, okay? So if you're taking a limit and you get a number over 0, that is kind of a clue that you're approaching a vertical asymptote, and then we'll have to take two one-sided limits to determine whether you're approaching infinity, negative infinity, or it does not exist. So let's just recall how to find a vertical asymptote. Remember that to find a vertical asymptote, all you do is set the denominator equal to 0. So here, notice they're just given f of x's, so you just take the denominator, set it equal to 0. That's how you find a vertical asymptote. Now here, the directions are slightly different because now it's a limit. So notice up here it was just an f of x, but now we're evaluating a limit. So when you find a limit approaching a number, the first thing you do is try to plug in. So you plug in x equals 3 there, and you end up with negative 4 over 0. So that kind of makes me sad because I wish it was a number so that I could be done. But then I remembered that, oh, this is a number divided by 0. That means I'm hitting a vertical asymptote. So, one of two things is going to happen. So I'm just going to bring this over here. So, I don't know, say there's some vertical asymptote here. Either both pieces are going to be headed, both branches are going to be headed the same direction. So here, if I'm approaching from the left, I'd be headed towards infinity. And if I'm approaching from the right, I'd be headed towards infinity again. So I don't know, say this was like x equals 2 there. So here, the limit as x approaches 2 of, let's just call that f of x, here it would equal infinity, okay? But you could also have an example, okay, we'll just call that x equals 2 again, okay, so there's a vertical asymptote at 2. What if you have one branch is approaching infinity, but the other branch is approaching negative infinity? So in this case, we would say the limit does not exist. So again, when you're approaching a vertical asymptote, there's two choices. You're either going to be heading towards infinity or negative infinity. If both the left hand and the right hand side are headed towards the same infinity, it could be positive infinity or, they could both be approaching negative infinity, okay? Then we would say, yes, the limit exists and it's that infinity. Right here, the limit as you approach 2 would be positive infinity. Here, if you had both of them heading down, you would be, the limit would be negative infinity. Or you could have the case where one branch is headed one direction and the other branch is headed the other direction, and here the limit would not exist, okay? So here, the limit as x approaches 2 does not exist for some f of x there. Okay, so that's kind of our goal with these next ones, is to take a look and see what's happening there. Okay, so here, again, you always try to plug in the number first. Whenever you're evaluating a limit approaching a number, your first strategy is to plug in. So you plug in, you get a number over 0. That tells you there's a vertical asymptote. Well, how do we do this algebraically? We're going to take the limit as you approach from the left-hand side, and then the limit as you approach from the right-hand side. So notice that I don't care what the output is. I only care about what infinity you're approaching, okay? So here, I kind of think of a number just slightly to the left of negative 2. So maybe like negative 3 or negative 2.5. And since I'm only caring about the positivity, the numerator here would be positive. The denominator, if I plugged in a negative 3 plus 2 would be a negative, and a negative cubed is still negative. So from the left-hand side, that branch is headed towards negative infinity. From the right-hand side, okay, when you plug in, that branch is headed towards positive infinity. So since this branch is headed towards negative infinity and this branch is headed towards positive infinity, they're not the same. So it would be like this example, where they're headed different directions. So then we would say the overall limit does not exist. Recall, if you just have the limit with no little plus or minus, that tells me that you already took into consideration both sides of it, okay? Where on this example, when you go to plug in a number slightly to the left of 3, so 2.99999. If I plugged in 2.99, I'd have a negative in the numerator, and then I would have a negative here, but then you square it, so it's going to be positive, okay? And so a negative divided by a positive is negative infinity. Then when I plug in a number to the right of 3, so 3.1, so the numerator is still negative. 3.1 minus 3 is positive, but you square that, still positive, so I have a negative. Notice since both branches are approaching negative infinity, then we say that the limit does exist and it is approaching. So that would be something like this one right here, where they're both headed towards negative infinity. So that's how you find a limit approaching, that's how you evaluate a limit when you get a number over 0. I'm going to pause and switch pages. Okay, so we have this here. The next thing you might be asked to do is evaluate the limit given a piecewise. So this is different than having a vertical asymptote, because you get a vertical asymptote when you plug in, you get a number over 0. But it's slightly similar because to evaluate a piecewise, what you're going to do is take two one-sided limits. So here, remember these are the constraints, and so it tells you which part of the equation you're allowed to plug into. So if I'm taking the limit as you approach from the left, okay, I'm still going to plug in -2. So that's where it's different than if you're just doing a vertical asymptote, because I'm still going to plug in -2. But this tells me which part of the equation I plug into. So if I'm approaching from the left, then I'm plugging into this one, like where you're going less than -2. So from the left, I plug into this one. I got a 9. Now I'm taking the limit as you approach from the right. So again, I'm still plugging in that -2, but this time I'm plugging into that equation because I'm approaching from the right. So when I plugged in there, I got 7. So then you'd say the limit overall does not exist because the left-hand limit and the right-hand limit are not the same, right? As you approach from the left and you approach from the right, those are not equal, so the limit does not exist. Just a note, on a test, I would not give you these two questions. I would just give you this and then ask you that question. You would need to know, oh, to find the limit of a piecewise, I need to take into consideration the two one-sided limits. Okay, so you've got that. And then the last thing for the day 2 notes that we went over is horizontal asymptotes. So the difference here, you have a limit approaching infinity. Okay, so sorry, I lost my train of thought there. So a limit approaching infinity. So that's different than a limit approaching a number. So whenever you're asked to evaluate a limit approaching infinity or negative infinity, you should be thinking that is code for them asking me if there's a horizontal asymptote. Okay? So just recall how to find a horizontal asymptote. You find a horizontal asymptote by comparing the degrees of the numerator to the degree of the denominator. So there's 3 examples here. Here the degree is bigger in the bottom. Here the degree is larger in the top, and in this example the degree is the same. So if the degree is larger in the bottom, there's a horizontal asymptote at y equals 0. If the degree is larger in the top, that means there is no horizontal asymptote, but there is a slant asymptote. And if the degrees are the same, then remember you grab the coefficients to get the horizontal asymptote. Well, I'm telling you that this first one and the third one are the 2 easiest, because if there is a horizontal asymptote, that is the limit as you approach infinity. So if you get this first or the third, then you're done. You just find the horizontal asymptote and you're like, that's my answer. The problem is when you try to do, when you try to find if there's a horizontal asymptote and the degree is bigger in the top, or I call that top heavy. So to do this, what you're going to do, your strategy there is if it's top heavy, aka there's no horizontal asymptote, we're going to plug in infinity, whichever infinity you're approaching. So if it's telling you positive infinity, you plug in positive. If it's approaching negative infinity, you would plug in a negative infinity. And again, I put that in quotes because remember, infinity is a concept, it's not a number, so we're not really plugging it in. But what we're trying to do is see where this thing is headed. So if you recall from pre-cal or when you graphed rationals, if there's not a horizontal, that means that there's some sort of a slant asymptote. And so remember, that kind of looks something like this. Might have something like that going on. So as you're approaching infinity, the y values there would be taking off towards infinity or towards negative infinity. So again, we are more concerned about which infinity you're taking off towards, and then we'll that's where you're headed is the limits there. So I'll kind of go through a couple here. So notice the difference. The limit is approaching infinity this time, not a number. Okay? So the first thing I say, if the limit is approaching infinity, that's asking me, is there a horizontal asymptote? In this case, since it's the same degree in the numerator and the denominator, we say that it's balanced, and we just grab those coefficients. So here it's negative 3 divided by 3, so here the limit is negative 1. Okay? Very similar down here. Here the degrees are the same, right? They're both linear. Or over here the degrees are the same. Okay? So if the degrees are the same, it's balanced. You just grab the coefficient. So 1 divided by 1, that's where this one came from. Over here, negative 5 over 2. Okay? So those are some examples of where the degree is the same. Now, you may have where it is bottom heavy, okay, where the degree is larger in the denominator. So that's like this one. So it doesn't matter that it's approaching negative infinity. It's still bottom heavy, so that tells me there's a horizontal asymptote at 0. And let me find another one. Is there another one that's bottom heavy? Nope, I guess there's not. Okay, so there's that. All right, so then let's take a look at one that's top heavy, right? So we did one where they were the same, one where it was bottom heavy. Now let's take a look at where they're top heavy. So this whole row here, 7, 8, and 9, they're all top heavy. And to do that, I kind of made a note. There's no horizontal asymptote for each of these. They're top heavy. So if it's top heavy, what you're going to do is you plug in infinity. If you plug in a positive infinity and square it, you get a positive. If I plug in a positive infinity here and subtract 5, I still get a positive number. So that means that this one is headed towards infinity. Okay, the y values are taking off. There's some sort of slant asymptote here, but this is the part of the branch where you're headed off to positive infinity. Now over here, when I plug in, because it's top heavy, I know that there's a slant, so I have to plug in infinity. And this time when I plug in the infinity, it's a negative. So a negative squared is positive, but a negative infinity minus 5 is a negative. So that tells me that this one is headed towards negative infinity. Okay, so that's how you do that. And then you'll notice there's a couple where the horizontal asymptote rules don't really apply because you're like, how do I compare the degree if it's some sort of trick? Well, this one is a little bit harder. You have to kind of visualize what this is going to look like. You can't compare the degree because, the degree of a trig function, like that doesn't, it's not like the others. So what you can do is think of sine of some number, so some huge number. Well, your sine curve is bounded between negative 1 and 1. So you could think of this as you're going to have some sort of number, okay, some number between negative 1 and 1, and then divided by, if you're approaching infinity, you're dividing by something huge, okay? So you might be saying some number divided by something huge. That's going to tend towards 0. If you're thinking about it in terms of like a physics application, you might call that the curve would be dampening, right? Like you'd start off really wide and then it'd kind of dampen off and just kind of oscillate back and forth, okay? Okay, so those are the limits approaching infinity. Hope that was helpful, and you can go ahead and start on the day 2 homework now. Have a great day.